Welcome to Lesson 8, Sandboxing and Hardening. Here's the uncomfortable truth. Every service you run is one CVE away from a root shell, and never have bugs isn't a strategy. What system gives you is the next best thing. Container-grade isolation without the containers, in roughly 5 lines per unit file. We'll walk the 4 families that matter. The protect star directives that shrink kernel and system surface, capability dropping to strip root down to what it actually needs, file system isolation, and network restrictions. 5 lines. Radically smaller blast radius. That's the deal. So before we touch a single directive, let's frame why we're doing this. Hardening isn't about preventing compromise. That ship sails the moment a CVE drops. It's about answering 4 questions after the breach. Can the attacker read other services' files? Can they escalate to root? Can they touch the kernel? And can they talk out to the network? By default, the answer to all 4 is yes. A compromised Nginx reads your Postgres data, your SSH keys, loads kernel modules, opens raw sockets for C2. Hardening flips each of those to no, and that flip is what shrinks the blast radius from catastrophic to contained. Look at the same Nginx, the same remote code execution, side by side. On the left, the default unit, 5 lines, no protections. And the attacker walks off with shadow files, home directories, raw sockets, kexec, the lot. Game over. On the right, 5 extra directives. ProtectSystem, ProtectHome, PrivateTmp, NoNewPrivileges, restrict address families. Same breach, but now the attacker owns a PrivateTmp and not much else. Identical cost, night and day outcome. So let's meet the first family, the protect star directives. 8 one-liners, each a yes or no switch, each closing off a whole category of attack. ProtectSystem and ProtectHome lock down the file system. The 4 kernel ones, tunables, modules, logs, control groups, shrink kernel surface. Protect clock and protect host name stop an attacker rewriting time or identity. And PrivateTmp. Private devices give you a clean slate per service. Default to defense. Turn them on, then justify any you leave off. On to family 2, capabilities. Linux shattered root into about 40 discrete powers, and here's the dirty secret. Most services need 0 or 1 of them, but by default, they inherit the entire set. The pattern is simple. Empty capability, bounding set to drop everything, then add back only what the binary truly needs, and realistically, 5 caps cover 99% of legitimate use. Bind to low ports, raw sockets, set the clock, override file perms, signal other users' processes. Everything else is just attacker convenience. Back to family 1 for a deeper cut. The protect switches are blunt instruments. The path directives are scalpels. Protect. System coster strict makes the entire file system read-only, then read-write paths punches surgical holes only where the service legitimately writes. Look at the Nginx block. Logs, cache, runtime. That's it. Add inaccessible paths for anything you want to vanish entirely, returning NOINT as if it never existed. The rule to memorize, strict plus an explicit write list equals your production baseline. Now families 3 and 4, kernel surface and network. Restrict address families cuts the socket types your service can even open. For a web server, AF INET and AF INET 6 are all you need. And dropping AF packet alone kills entire classes of sniffing tools. System call filter goes deeper, narrowing the kernel ABI to a vetted allow list like ABSystem service, while explicitly stripping ear privileged. And IP address, DNI paired with a tight allow turns egress into a whitelist, so a popped service can't phone home to a C2 server. 3 directives, 3 attack surfaces gone. So step back from the directives for a moment and ask why this is now baseline. 3 principles. 1. Compromise is when, not if. Every dependency carries CVEs, Patching is always reactive, so you design for blast radius up front. 2. 5 lines in a unit file beats 5 days of incident forensics, and the ROI lands on the very first event you prevent. 3. System to Analyze Security is your dashboard, a free 0 to 10 exposure score on every service. Anything under 5 is actively dangerous, and engineers who don't run it are operating blind. So here's the practical takeaway. 12 lines, 1 block, pasted at the top of every new service section you write from today onward. Notice the shape, a non-root user, then the 4 families we keep coming back to. Filesystem locked down with ProtectSystem, ProtectHome, PrivateTmp, private devices, kernel surface sealed with the 3 protect kernel directives, network narrowed to just inet and Unix, syscalls filtered to the system service set, and capabilities dropped to none. The default posture is on. You only peel something off when the binary genuinely breaks, never the other way around. Reading about it isn't enough. You need the muscle memory, so here are 3 drills, 60 to 90 minutes total. First, run System to Analyze Security and rank every unit on your box. That's your inventory of security debt. Second, pick the worst offender, paste in the starter pack, restart, and watch the score drop. That's the harden test iterate loop you'll repeat for years. Third, prove it works. Try to read, etc. shadow from inside the sandbox, watch it fail, and save the journal entry as evidence. Score, harden, verify. That's the pattern. Now, the failure modes, because hardening goes wrong in 2 directions. Too loose and you've built a theater set, too tight and you're paged at 3 in the morning. The classics, ProtectSystem full when you meant strict, forgetting read-write paths, so Nginx can't write its own logs, emptying CapabilityBoundingSet, and discovering at runtime you needed cap net bind service, system call filter that trips on a rare syscall under load, and the one everyone does, hardening the user-facing service, while the cron job and the metrics scraper still run as root. Trust System to Analyze, test under real load, and harden every service. No exceptions. So that's Lesson 8. 4 families covered: Protect Star, capabilities, file system isolation, network and syscall filtering, and a service that's genuinely smaller as a target after the inevitable compromise. 5 lines, real payoff, ship it on every unit. Next up, Lesson 9, resource control with C groups, CPU, memory, and I/O limits per service, noisy neighbors solved declaratively, no containers required. See you there.